Hi there, and welcome back to my Precalculus video series, where my goal is simple, to make Precalculus make sense. Now, whether you're here to get ahead, catch up, or finally understand what your textbook is trying to say, you are in the right place. In our last lesson, we tackled the fundamental properties of real numbers, the commutative, associative, and distributive properties. If you've missed it, no worries, you can find that video right here. Today, we're diving deeper into addition, subtraction, and the often misunderstood properties of negative numbers. These are concepts you've used for years, but let's uncover the why behind them, so they become intuitive and not just rules to memorize. By the end of this video, you'll be able to 1. Grasp the meaning of the additive identity and additive inverse. 2. Rewrite subtraction as the addition of a negative number. 3. Apply the properties of negative numbers to simplify complex expressions. And 4. Confidently use the distributive property with negative terms to rewrite and rearrange algebraic expressions. Thank you for being here. Now let's get started. You've probably been adding and subtracting since elementary school, but Precalculus is all about digging deeper into the foundational logic. For instance, why is 0 so special that it's called the additive identity? Why is subtracting a positive number the exact same as adding a negative one? And how can we confidently simplify trick expressions like this, negative x plus y minus z? How can we simplify that? It's time to clear up what's truly going on when we work with positive and negative numbers. We are going to begin with the additive identity. The additive identity is 0. 0 is known as the additive identity because, quite simply, adding 0 to any number does not change that number's identity. Here is the rule. If I have any number a and I add 0 to it, it's going to remain with the same value as a. Now here's an example. If I do 5 plus 0, the value of that is still 5. If I take x plus 0, the value is still going to be x. And that is the additive identity. Next is the additive inverse. Now every real number has an additive inverse, which is the number that, when added to it, results in 0. Let me show you what that means. Here's the rule for the additive inverse. If I have some number a, I need to add something to it to give me 0. The answer here is that I need to add the opposite of a. So in this case, it'll be negative a. Here's a quick example. If I have 7 and I want to find its additive inverse, well, I need to search for a number that when I add 7 to it, it's going to give me 0. 7 plus what will give me 0? That answer is negative 7. So to find the additive inverse, you're going to take whatever it is that you have, whether it's a variable or whether it's just a number, and you're going to change its sign. That will become its additive inverse. This concept is the true foundation of subtraction. We don't actually subtract in the purest sense. Instead, we just add the opposite. So what that means is that if I have a minus b, this is what we know as subtraction. But what it really is, it's a plus negative b. Subtraction is just another type or another form of addition. Next are the properties of negatives. Here are 6 incredibly useful properties that will empower you to confidently simplify expressions involving negative numbers. Here's property 1, which says negative 1 times any number a is going to be negative a. Here's an example. If I have negative 1 times 5, the result will be negative 5. Here's property number 2. If I have negative of negative a, this is going to be just positive a, because a negative times a negative will give me positive. So if I have a minus negative 5, this will just result in being positive 5. Here's rule number 3. If I have negative a times b, that is the same thing as positive a times negative b, which is also equivalent to negative a times b. Here's an example. I could take negative 5 times 7, but that's going to give me the same result as if I multiply positive 5 and negative 7, which will result in negative 35. Here is property number 4. If I have negative a times negative b, that results in a times b, because the negative times a negative is a positive. So a quick example, if I have negative 4 and I multiply that by negative 3, that will give me positive 12, because negative times negative is a positive and 4 times 3 is 12. Here's property number 5. If I have negative of a plus b, that will result in negative a minus b. Here's an example. If I have negative 3 plus 5, this will be equal to negative 3 minus 5. which would just be negative 8. And here's property number 6. If I have negative of a minus b, this will result in negative a plus b, which you can rewrite as being b minus a. A quick example is negative 5 minus 2. You can rewrite this as 2 minus 5. Properties 5 and number 6 especially are going to be your best friends when dealing with longer, more complex expressions. They allow you to distribute that negative sign effectively. And so in properties 5 and 6, we are taking advantage of that distributive property. So the negative gets distributed to a here to give me minus a, and the negative distributes into positive b, which gives us minus b. So that's what we see in property 5. Now in property 6, you're going to see that it's possible for you to flip the order because the sign has changed. So here I have negative times positive a. That gives me negative a. And then I have the negative multiplied into negative b. Negative times a negative, as we saw earlier in property 4, is going to be a positive b. And so instead of writing negative in the front, it's easier to write it as what we typically know as subtraction. And so we can just put the positive in the front, b, and then we add on that negative a, which could be just written as b minus a. Here is a quick example of property 5. Let's simplify negative x plus 2. If I start off with negative x plus 2, I can distribute this minus sign into x. So negative times x is going to be negative x. And then the negative times the 2 is going to result in minus 2. And then also, in case you didn't know, when you have a negative in front, we treat the value as it being just a 1, a value of 1. Let's return to the example that I wrote down in the very top. Now, let us simplify negative x plus y minus c. Well, all that we have to do is distribute this negative into each of the terms inside the parentheses. So negative times x is minus x. Negative times a positive y is going to be minus y. And then a negative times negative z is going to be a positive z. Here's a crucial point that often trips students up. The opposite of a number isn't always negative. Let's say a is a positive number. Let's let a equal to be positive 5. Then if I want to find the value of minus a, then that's going to be minus and then the value of a, which is 5. And that will be negative 5. But if I let a be equal to a negative number, so a itself is a negative number, so let's put negative 5. Then if I want to find what the value of negative a is, then I have to write the negative first, and then I'm going to substitute the value of a. But a is already a negative number. So negative negative 5, this follows property number 2. And so negative negative 5 will be equal to positive 5. So never assume that the expression negative a means the result will be a negative number. It entirely depends on the value of a itself. Let's quickly review the key takeaways from today's lesson. We learned that 0 is the additive identity. A plus 0 is equal to a. Every number has an additive inverse, which is its opposite, which sums to 0. A plus minus a is equal to 0. We solidified the understanding that subtraction is fundamentally just adding a negative number. And finally, we practiced using the powerful properties of negatives to simplify expressions. Master these concepts now, and you'll build an incredibly strong foundation that will make understanding algebra and even calculus significantly easier down the road. In our next lesson, we're going to shift gears and dive into multiplication and division of real numbers. If you found this video helpful, please hit the like button and consider subscribing so you don't miss out on any future lessons. Thank you for spending some time with me. I will see you in the next lesson.